Welcome. So this question says a block moves in a circle. It has a centripetal acceleration of 9 meters per second squared. What is the centripetal acceleration of a new block if it has triple the mass and 4 times the velocity of the old mass, and it follows a path that has twice the radius of the old path? So what we've got here is we have a situation where we're doing basically a ratio problem. I have one situation here where I know the AC is equal to 9 meters per second squared. And then I'm going to compare it with another situation. And I link these guys by basically knowing how things change. I don't have absolute numbers. I just have something doubles, something halves, triples, quarters, whatever. So the first thing I've got to do is I've got to recognize the relationship that links AC with some of these other things. And what am I given? I'm given a mass, I'm given a velocity, and I'm given a radius. And what comes to mind is that AC equals v squared over r. Now, that's not included mass, but I don't care. Not everything that's given to me in a good test question need be used. If we only ever tell you exactly what you need, then it's a real help in deciding what equation to pick. But life isn't like that. Life just says, here's 101 things. Pick out whichever things you need. So I like to throw in additional issues just to let people chew on the additional information. It's called a red herring, and they're very valuable. So yeah, mass is not going to be included, so I don't care how it changes. So then we say, okay, how do we do these? And a big part of it is layout. We're going to say AC new is going to equal over AC old. AC old, let's get rid of that. Let's move that equal sign down. Is equal to, well, it's going to be the V new squared over the R new divided by the V old squared over the R old. I've just taken that relationship and I've said, well, the ratio of the new must equal the ratio of the old. So if I progress, I say, well, my AC new over, I knew the value for the old centripetal acceleration. That was 9. So AC new over 9 is equal to, and I don't know the new value of the tangential speed. I didn't know the old value of the tangential speed, but I knew that it's 4 times. So the tangential speed has increased 4 times. So why not call it 4 and 1? That's 4 times bigger. I could have called it 2 and 8, or 2,000 and 8,000, or a half and 2. But it just seems to me if it's 4 times bigger, just make it 4. And the original value was 1. It keeps my life simple. I've got to square it, of course. And then I'm going to divide this by the radius. And it says the radius has twice, is doubled basically. It's twice as much. So the new one is twice what the old one was. And can you see how if I lay it out like this, then underneath becomes 1. So I have 4 4s are 16, divided by 2 is 8. So then I say, oh, okay then, AC new is going to equal 8. It was divided by 9 times 9. is C new 9872, 72 meters per second squared. So this is a classic ratio problem. You don't always know the absolute values. You sometimes know that you double something, or you quartered something, or you triple something. And under those circumstances, the arithmetic is relatively easy. The problem is that people will, in their head, get things upside down and backwards. That's why doing conversions is sometimes a problem, unless you have a decent layout. So this is the layout that I use. I put my new thing over my old thing, and I carefully lay out the equation, and then I use the simplest ratios. So if something doubles, I use 2 and 1. If something triples, I use 3 and 1. If something halves, I use the half and 1. It's the way I do it. And I just let my mathematics go, and I get my answer. Make far fewer mistakes doing this than I ever did trying to figure it out in my head. So there we have it.